Running metal-clad cable, also known as MC cable, directly embedded in a finished brick wall to supply power to a light fixture without using a junction box or a shorting bushing constitutes a violation of electrical safety codes. The National Electrical Code, or NEC, provides detailed regulations concerning the proper installation and protection of electrical wiring methods, including MC cable. The primary reasons why this installation method is non-compliant and unsafe revolve around physical protection, grounding and bonding, and prevention of short circuits and ground faults. Firstly, physical protection is paramount. MC cable, while having a metallic armor, is not designed to be directly embedded in abrasive materials such as brick or concrete without additional protection. The sharp edges and rough texture of brick can damage the cable's outer jacket over time, especially with thermal expansion and contraction, and physical movement. This damage can expose the insulated conductors inside, creating a risk of electrical shock or fire. The NEC mandates that wiring methods be adequately protected from physical damage. Direct contact with brick without a protective conduit or raceway does not meet this requirement. Secondly, grounding and bonding are critical for electrical safety. The metallic armor of MC cable serves as an equipment grounding conductor, providing a low impedance path for fault current to return to the source in the event of a ground fault. This path facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses, which disconnect the circuit and prevent electrical shock or fire. When MC cable is cut flush with the brick wall and directly connected to a light fixture without a proper termination inside a junction box, the integrity of the grounding path is compromised. A proper termination ensures a secure and reliable electrical connection between the cable armor and the metal frame of the light fixture, or the grounding system. Without this secure connection, the grounding path may be ineffective, increasing the risk of electrical shock. Thirdly, the prevention of short circuits and ground faults is another important consideration. A short circuit occurs when there is an unintended electrical connection between two or more conductors with different electrical potentials. A ground fault occurs when there is an unintended electrical connection between a conductor and a grounded surface, such as the metal armor of the MC cable or a grounded metal component of the building. Both short circuits and ground faults can result in high currents, overheating, and potentially fire. When MC cable is embedded directly in a brick wall without a shorting bushing or proper termination, there is an increased risk of the cable's insulation being damaged, leading to a short circuit or ground fault. The sharp edges of the cut MC cable and the abrasive nature of brick can compromise the insulation, especially over time. A shorting bushing, also known as an anti-short bushing, is a small insulating fitting that is installed on the cut end of MC cable to protect the conductors from abrasion and prevent them from coming into contact with the sharp edges of the cable armor. This bushing is essential for maintaining the integrity of the insulation and preventing short circuits and ground faults. The practice of using the light fixture itself as a junction box is also a violation of the NEC. A junction box is an enclosure specifically designed to protect electrical connections and provide a safe and accessible location for making splices or terminations. Light fixtures are not designed to serve as junction boxes, and they typically do not provide adequate space, protection, or access for making proper electrical connections. Furthermore, using a light fixture as a junction box can create a fire hazard if the connections are not made correctly or if the fixture overheats. To comply with the NEC and ensure electrical safety, several steps must be taken. Firstly, a junction box must be installed in a brick wall to provide a safe and accessible location for terminating the MC cable. The junction box should be securely mounted to the wall and sized appropriately for the number and size of conductors being terminated. Secondly, a shorting bushing must be installed on the cut end of the MC cable to protect the conductors from abrasion. The bushing should be properly sized for the cable and securely attached to the cable armor. Thirdly, the MC cable must be properly terminated inside the junction box using approved connectors. The connectors should be designed for use with MC cable and should provide a secure and reliable electrical connection. Fourthly, the equipment grounding conductor in the MC cable must be connected to the grounding system using an approved grounding connector. This connection ensures that the metal frame of the light fixture is properly grounded, providing a low impedance path for fault current to return to the source. Fifthly, the light fixture must be properly mounted to the junction box and securely connected to the electrical wiring. The fixture should be listed for use in the intended location and installed according to the manufacturer's instructions. Specific sections of the NEC that address these requirements include Article 300.4, which covers protection against physical damage, Article 312, which covers cabinets, boxes, and enclosures for conductor terminations, and Article 320, which covers armored cable type MC. In addition to these specific sections, other relevant articles in the NEC provide general requirements for electrical installations, including grounding and bonding, overcurrent protection, and wiring methods. It is important to consult the latest edition of the NEC and any applicable local codes or regulations to ensure compliance with all requirements. For example, NEC Section 300.4 D addresses protection against damage from screws and nails. When installing cables or raceways through wood framing members, metal plates or bushings are required to protect the wiring from penetration by screws or nails. Similarly, NEC Section 314.17 specifies the requirements for the number of conductors permitted in outlet device and junction boxes and conduit bodies. Overfilling boxes can lead to overheating and insulation damage, increasing the risk of electrical hazards. NEC Section 312 provides requirements for the installation and use of cabinets, cutouts, boxes, and meter socket enclosures. These enclosures must be securely mounted and provide adequate space for conductors and splices. They must also be protected from physical damage and corrosion. NEC Article 250 covers the requirements for grounding and bonding electrical systems and equipment. Proper grounding and bonding are essential for electrical safety, as they provide a low impedance path for fault current to return to the source, minimizing the risk of electrical shock and fire. It is also important to consider the specific environment in which the electrical installation is being made. For example, if the brick wall is located in a wet or damp location such as a bathroom or outdoor area, additional precautions must be taken to protect the wiring from moisture. This may involve using weatherproof junction boxes and fittings, as well as moisture-resistant cable. Additionally, the type of MC cable used should be appropriate for the environment. For example, MC cable with a PVC jacket is more resistant to moisture than MC cable with a standard aluminum jacket. In summary, embedding MC cable directly in a brick wall without proper protection and termination is a violation of electrical safety codes and can create a significant risk of electrical shock or fire. To ensure compliance with the NEC and protect the safety of people and property, it is essential to install a junction box, use a shorting bushing, and properly terminate the cable using approved connectors. Always consult the latest edition of the NEC and any applicable local codes or regulations before undertaking any electrical work, and when in doubt, consult with a qualified electrician. Understanding the relevant NEC articles and adhering to best practices in electrical installation are crucial for maintaining a safe and reliable electrical system. Remember that electrical codes are in place to protect people and property, and compliance is not merely a suggestion but a legal requirement. Failure to comply can result in fines, penalties, and more importantly, serious injury or death. Consider a scenario where MC cable is run through a brick wall without a junction box and the brick wall is exposed to moisture. Over time, the moisture can penetrate the MC cable and corrode the conductors. This corrosion can lead to a loss of conductivity, causing the light fixture to flicker or not work at all. In addition, the corrosion can weaken the insulation of the conductors, increasing the risk of a short circuit or ground fault. If a short circuit or ground fault occurs, the circuit breaker may trip, shutting off power to the light fixture. However, if the circuit breaker fails to trip, the high current can cause the MC cable to overheat, potentially leading to a fire. Now, let's consider another scenario where the MC cable is run through a brick wall without a shorting bushing. The sharp edges of the cut MC cable can rub against the insulation of the conductors, especially when the cable is subjected to vibration or movement. Over time, this rubbing can wear away the insulation, exposing the conductors. If the exposed conductors come into contact with the metal armor of the MC cable or a grounded metal object, a short circuit or ground fault can occur. This can result in an electrical shock if someone touches the metal object, or a fire if the high current ignites nearby flammable materials. These scenarios illustrate the importance of following electrical codes and using proper installation method. By installing a junction box, using a shorting bushing, and properly terminating the MC cable, the risks of electrical shock, fire, and equipment damage can be significantly reduced. Moreover, regular inspections and maintenance of electrical systems can help identify potential problems before they become serious hazards. These inspections should be performed by qualified electricians who are familiar with the NEC and local codes. They can check for signs of damage, corrosion, or loose connections and make any necessary repairs or replacements. The NEC also provides guidelines for the proper selection and sizing of electrical equipment. For example, it specifies the ampacity of conductors based on their size, insulation type, and installation conditions. It also provides requirements for the overcurrent protection of circuits, ensuring that circuit breakers or fuses are properly sized to protect the wiring and equipment from overloads and short circuits. Furthermore, the NEC addresses the installation of electrical equipment in specific locations, such as hazardous locations, healthcare facilities, and swimming pools. These locations require special precautions to prevent electrical shock and fire. For example, in hazardous locations where flammable gases or vapors may be present, explosion-proof equipment is required to contain any potential explosions. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is constantly updated to reflect new technologies and best practices. By staying informed about the latest edition of the NEC and following its requirements, electrical professionals can ensure the safety and reliability of electrical systems. In conclusion, the NEC is a vital resource for electrical safety. It provides detailed guidelines for the proper installation, maintenance, and inspection of electrical systems. By adhering to the NEC, electrical professionals can protect people and property from the hazards of electricity.